A is simply f of x is equal to 4 minus x squared. So what's the domain of a quadratic function, guys? What's the domain of a quadratic? What's the general thing that we said? Anyone, guys, what's the domain of a quadratic? Yes, so here it's fixed. As long as it's a quadratic, guys, the domain is always going to be the set of all real numbers, unless otherwise they've restricted the domain, meaning they're going to tell you, yeah, like that question from your tutorial sheet 2. For you guys doing 1100, the last question there, they wrote something like 2x squared, then what? Plus minus 3. There was a minus 3. Then they said the domain is all real numbers, but x should be what? Less than 0. So they restricted the domain to say all numbers are allowed, especially or only those parts that are less than 0. That's what they basically mean when they restrict it. But on a normal day, all real numbers are allowed for a quadratic, which is this case here. Then the range, how we get the range, we said it depends on the value of a. So if a is less than 0, like this guy here, it's less than 0, meaning even the range will be y is less than or equal to 4ac minus b squared over 4a. This is how you get the range of a quadratic whose coefficient of x squared is a negative or it's less than 0. Yes. So y is less than or equal to, so we are putting where there's a, you put what? -1. Where there's c, we put a 4. B, there was no b, so we'll put a 0. This is 4 and -1. So this will just give you y is less than or equal to, this is a -16, then this is a -4. This will be y is less than or equal to a 4. So meaning all numbers less than what? Less than 4. So 4, you can just say the range is just -infinity to. You can say it's -infinity to 4 and it's closed. So this here will be your range. Yeah, so that answers your part number 1. Yeah, then part 2, part B of the question that I asked about Fermat domain and range. The part 2 was just saying f of x is equal to negative. So f of x is equal to -2, then root of x. So you just focus on the inside part. This is a radical function. So if it's a radical function, we said the domain is just the part which is inside. It should be greater than or equal to 0. Don't worry about anything outside, because this part outside is never going to be a problem. The only thing that can be a problem is this thing inside, because x must always be greater than or equal to what? 0. Because if you put anything negative inside the square root, you are not able to solve it. Yeah, so meaning here, this is straightforward. The domain will just be all real numbers that are greater than or equal to what? 0. That's what you have. Sometimes they can say, show this on the number line. So this is just going to be from here, just going this side. Yeah, so this is our domain. Then the range. What's the range here, guys, going to be? What's the range of this function? The radical, whenever you are dealing with a radical function, you can either have the following cases. It's either you have something that looks like this, meaning the coefficient of x is positive, or you have something that looks like this, meaning this guy here is negative. You can have something that looks like that. Then I also want to show you all the 4 pieces here at once. Yeah, so the other one we said is if, so this is the one, so if we reflect it this side, this is if you have what? Negative root of x. Then the other one is if you have negative of both. So meaning if the outside there's a negative and also inside x has a negative. So this example, this question that we are dealing with is this case here, yeah, which is case C, meaning it's from 0 up to what? 0 up to down. So here the domain is x is greater than 0. You are seeing even here the domain is x less than 0. The domain here is greater than or equal to, less than or equal to, greater than or equal to 0. Then here it's less than or equal to 0. The range, here the range will just be y is greater than or equal to 0. The range here will be y is greater than or equal to 0. In these two cases down, the range is y is less than or equal to 0. So this guy that we're dealing with, the range will just be y less than or equal to 0 because it's facing down. In short, it's from negative infinity up to 0. This is what you'll get. So for radical functions, before you even solve, you need to know how it's going to look like. So if the coefficient of x is positive, meaning the number in front of x, so how this has come out is how anything that looks like this is going to be given. Even if I give you x minus 4, provided the coefficient of x, so what's in front of x, as long as it's positive, your graph will always look like the first one. Then provided this guy here, the example is like I give you 3 minus x. If the coefficient of x is negative, your graph will always look like this. Yeah, so these are the 4 cases that you need to look out for. Hope this is okay, guys. We're just saying the domain is all numbers that are greater than or equal to 0. The range is all numbers from 0 going down. Yeah. Mwaba, Christopher, is this okay? Your part 2. Have you?
Yes, it's okay. I've understood.
Okay. So now you also said what? You also said part 3.
Yes, part 3, sir.
So part 3 is a quadratic. We said whenever you have a quadratic in, so this is k of x, you have a quadratic in a radical expression. This is 4 minus x squared. So we know to say the domain should have been 4 minus x squared, then greater than or equal to what? 0. That's what we know. So this is a quadratic. So we'll solve it with an equal sign first. When we solve this with an equal sign, this is going to be that x squared is equal to 4. When you square root this side, the answers you get are going to be 2. You can either have a plus or minus 2. Then we have to check, so we'll put the negative 2. You only do this if you have a quadratic under a radical function. The question was minus 4x squared. So we're just going to test here. If you put any number less than, so I'll put this guy here. I'll use a 0 there. I'll use a 3 there. If I put negative 3 here, this is going to be 4 minus 9. This is negative 5. The answer here is negative. If I use a 0 there, the answer there is positive. I use a 3 there, that's going to be 4 minus 9 again, which is negative. Because 4 minus 9, that's negative 5. We want a portion where this thing is greater than or equal to what? 0. So it's only greater than or equal to 0 between these. So x has to come from negative 2 up to 2. The reason why this is closed is because this was greater than or equal to, meaning the boundaries are allowed because they will give us 0. The square root of 0 is 0. We are able to calculate that. So no wonder these guys are part of the answer. So it's closed between negative 2 to 2. That's where this whole thing is positive. So this is how we get the domain of this mixture of a radical and a quadratic. To get the range, you'd have to get the inverse first. The inverse will help you. So this is, I'll just say h of x is equal to, we have 4 minus x squared. The inverse of this, you let y come this side. This is what you get. Then here now, you can just square both sides. This will be y squared is equal to 4 minus x squared. Then take the 4 this side. This is negative x squared. Divide by negative, divide by negative. So this will be x squared is equal to negative y squared plus 4. This here is the same as 4 minus y squared. So x is the same as 4 minus y squared. You notice that the original function and the inverse are all the same, because here even h of x, this is giving you what? You notice you are getting 4 minus x squared. So if a function is similar to its inverse, we say the domain and the range are going to be the same. So the same answer that we got for the domain will also be the range. So the range will also be y should be found between -2 to what? To 2. Because the function h of this is the same as its inverse. Because initially we were supposed to get, we have the function, we got the domain. We wanted to get the inverse because once you know the inverse, the domain of the inverse is always equal to the range of the original function. The same way that the domain of the original function is the inverse, is the range of the inverse. So no wonder I wanted to get the inverse, so that once I get the inverse, I'm able to get the what? The domain. But then the domain here happens to be the same as the domain in the first equation, because the inverse and the original function are just the same. Yeah, so no wonder the answer has also been written like this. We just change where there's x, we put where there's x, we put y. Is this okay, Chris?
Yes, I have understood better, sir.
Okay, so always expect having a quadratic in a radical expression. Expect something like this, and then they'll ask you deliberately to say what's the domain of this. And whenever they put this, it's rare that they put they ask about the range. They'll just say domain. So expect something like this on your quiz. So you solve x squared minus 6x plus that has to be greater than or equal to what? 0. When you solve this quadratic, you get two answers separately, which is x is equal to and x is equal to 4. Once you get these two answers, you are supposed to test. So here we have a 4. So you pick any numbers, right? So you pick any number this side. I'll choose a 0. Yeah, 0 is actually correct. It's just okay because it's this side. A number in between here, I'll use a 3. A number afterwards, I'll use a 5. So if I put 0 in this whole expression, wherever there is x, we put 0. We're getting 8. Is 8 greater than 0? It's true, right? Yeah, so this is true. This is wanted. If I put 3 there everywhere, this is going to be a 9 minus 18, then plus this. This is just going to be negative. So this part here is false. The other part should be true because that will be 25. 25 minus 30, then plus 8. Yeah, this is going to be positive. Yeah, so meaning this guy here is true. So the domain here would have been, the domain would just be x should belong to negative infinity up to 2, closed, then union from 4 up to positive infinity. So this is what you get. You only use this table form whenever there's a quadratic in the radical expression. That's the only time we get to use this. Any questions, guys, here up to this point? One, find the values of k. Yes, for the questions that Daniel sent, they are saying find the values of k or the set of values for k in each case below. Yeah, so this is just, let me give you a recap on Polyvama, these things for the discriminant. So we said there are 3 cases. Before you solve any quadratic, you can find out the nature of the roots that you're going to get by simply getting the discriminant. This is what we call the discriminant. So the nature of the roots is dependent on the value of the discriminant. Yeah, so it will give you a rough idea of what you are to expect. So these are the discriminant. And when we said we use the first one, if you have 2 real roots, that's when you use the first one. We use the second one if you have 2 imaginary or complex roots. Yeah, so you have this. Then here you use this if you have 1 real root. That's when you use the last one for the equal sign. So now the first question there is saying find the values of k and the set of values for which for k in each case, given that the roots of 3x squared minus 12x plus k is equal to 0. The roots differ by 2. So the roots differ by 2. So this is also, maybe let me add on something here. Apart from this, we should also know to say, provided you have a quadratic equation that looks like this, remember that it will always produce two answers. Let's call them alpha and beta. And you know to say alpha plus beta is the same as negative b over a. And also alpha times beta is the same as your c over your a. So I hope you remember this. Now, here they are saying the roots of this guy differ by 2. So if the roots of this expression differ by 2, meaning e more is in alpha, then e more is in alpha plus 2. Or someone else would say one is alpha, then the other one is alpha minus 2. All we're just saying is that the difference between these two alphas is what? Is 2. Yeah, I mean these two roots. So it has two roots whose difference is 2. So I'll go with the first one. This one here that I've written. So one root is alpha, the other one will be a plus alpha plus 2. The summation of this is alpha plus 2 is the same as, we said alpha plus beta is the same as negative b over a. So this is negative, your b is negative 12, your a is simply your 3. This will be 4 alpha plus 2. Then this is going to be a 4. And then you're having 4 alpha is equal to 4 minus 2. Yeah, so we're having 4 alpha is equal to 2. We can divide by 2 this side, by 4. So alpha is the same as 2 over 4, which is 1 over 2. Once you get your alpha, you can get the other one, because the other one is simply alpha plus 2. Yeah, so we know to say there's alpha is this. We know alpha is half. So what's the product? The product is simply alpha times alpha plus 2. This should give us c over a. Your c there is the one that's k from your question. Your a is simply what? A 3. So according to our question here, our c is k, our a is simply 3. So we know to say, if we were to multiply those two roots, we should get c over a. Yeah, now just that in this case, the roots that we are multiplying are these two, because these are the roots that we have that differ by 2. So this is now going to be okay, so there's a 2 here. Okay, this is a 2, not an alpha. So we can put half here, then we have half plus 2, because we are from getting what alpha is. Alpha is half. So now we can replace so that we get the value of k. Then this is going to be 1 over 2 multiplying, this is 5 over 2. This is just going to be k over 3. This will be 5 over 4 is equal to k over 3. Then when you cross multiply, this is going to give us your 4k is equal to a 15. Then divide by 4. So k is equal to 15 over 4. So this is the value of k that was needed for that quadratic equation to have two roots that differ by 2. So the way the question is going to be phrased will be in such a way that they will guide you on how the alphas or the roots are related. So like the second one, maybe let me just do the second one. You see, maybe you'll follow this. They are saying there's a quadratic. The quadratic there has roots which are opposite. They are equal and opposite, meaning if the other one is alpha, the other one is negative alpha. They are equal but what? Opposite. That's what they mean. Yeah, so this is what you should be relating these to. 7x squared plus, then you're having k squared minus 4, k squared minus 4, then x, then this is minus 8 is equal to 0. So they want us to get the values of k, remember, and we know to say the summation when we add these two guys. Initially, you know, alpha plus beta should give us what? Negative b over a. So we're just saying the two alphas are these, the two answers are alpha and negative alpha. So when you add these, you get a 0. Alpha plus negative alpha, that's a 0. Negative, your b is simply k squared minus 4 over your a, which is just a 7. So this is now going to be 0 is equal to, this is negative k squared, then plus 4. Then there's a 7 down. We can cross multiply. This will just be 0 is equal to negative k squared plus 4. Take the 4 on the other side, or the k squared on the other side. This will just be 4. Then you square root, meaning k is equal to plus or minus 2. So these are the two values that you're going to get for k. So let me just take a breath. Are you guys following what we are doing here? Macnon, is this confusing? Okay, so Gamma alpha and beta, guys, you understand this thing. If I give you to say you have a quadratic, any quadratic needs to give you two answers. Now, how those two answers are related is dependent on the question. But we know to say these formulas are obvious. They are fixed. Yeah, so we don't know what alpha and beta are. But these formulas are standard. Formulas. Every quadratic needs to give you two answers. So like, let me solve part C. You see part 3. So part 3 they are saying there is a quadratic 3k plus kx then minus 2 is equal to 0. Has two roots whose sum is equal to 6. So they've told us to say ina maruti avili, still 0 maruti. But we just know to say their sum should give us what? Should give us 6. So each question will tell you how those roots are related to each other. Yeah, so the sum here is giving us what? 6. Now, we are interested in getting the value of k. That's what the main question was about. Getting the value of k. So, the only thing they've mentioned here is the sum. We don't know alpha and beta, but they are telling us to say, if you ever add them, the alpha and beta, you should get a 6. And we know to say alpha plus beta should have given us what? Negative b over a. Our b is simply negative. Our b here is k. Our a is 3. Now they said the sum of these guys should be what? Should be a 6. This will be negative k over 3. Then here you can cross multiply, meaning k is equal to your negative 18. So this is how you get it. Depending on how the question has been phrased, you use it to get the alpha plus beta, or the sum of those roots that are mentioned, and also the product. This is what you're always going to use to get any letter that you're interested in. So it's the same thing even here. In the same concept, even if they give you something weird, like this guy here, this is 2x squared. So you have minus k plus 2, then equal x. Then this is plus k plus 1 is equal to 0. They are saying has two distinct real roots. So this one here we use the discriminant. They're just telling us the nature of the roots to say, by the time you're done solving this guy, it has two roots, right? What's their nature? It has two real, distinct real roots. So meaning according to our discriminant, we're going to use the first case. We're dealing with this one. That's what we are going to be using. That's what they want. So now we are having our problem is this. So according to this, guys, Macnon, Ngavimveka, what's your A here? Your A is 2, right? What's your B here going to be?
Mine is going to be negative open brackets, k plus 2.
Then your c is going to be k plus 1, eh?
Yes, sir.
And then they said this thing has two real roots, meaning the discriminant for AC must be greater than 0. So where there is B, I can put negative k plus 2, then square this, minus 4. Where there is A, I can put a 2. Where there is C, I can put k plus 1. So this will just be k plus 1 greater than 0. So you can square the negative squared, then this times itself. This is just going to give us k squared, then plus 4k, then plus 4. Multiply this is negative 8k, then minus 8 should be greater than 0. This is k squared, this is negative 4k, then this is negative 4 should be greater than 0. When you reach at this stage, now we have to solve this because these were gathering like terms. So this is and that, and then you have 4 and negative that. So this is what you get. So now at this point you can now try to solve this, because we can just use the bus to solve this because we need to test afterwards. So meaning k is equal to negative b for a c, then 2a. Okay, so where there is a, we'll put 1. Where there is b, we'll put negative 4, so that will be positive. This is a 16. 4, negative 4. This is 2 and 1. This is 4 plus or minus. This is a 32. There's a 2. So we know to say 16 by 2 is what gives us 32. So we can just break it down because 32 is the same as 16 by 2. So the square root of 16 by 2, this is just going to be 4 root 2. Then down you have a 2. Then here you can divide both the numerator and the denominator by 2. So your final answer will just be this. This is basically what you get as the values of k. When we solved this, the discriminant expression, now we'll have to test, because we want where the whole expression, the k squared minus 4k, then minus 4, where is it greater than 0? That's what we're interested in. Where is this greater than 0? So we're testing. There is a 2 minus 2 root 2. That's a smaller one. Then there's a 2 plus 2 root 2. So we can use any number that you want this side. I'll go for the biggest. I'll get for negative 10. Any number here I can use a 0. Any number after this is 0 actually going to be part of this? Yes. Any number after this we can go for a 10. So if I put negative 10 wherever there is k in this expression, is the inequality going to hold? So there's 100, that's going to be 100, then plus 4, then minus that. So this will be, this is a plus here because there's a negative here, right? So okay, so this will be, this is going to be, okay, that's true, because the answer will be greater than 0. If you use a 0, that's going to be negative, so that's false. We use anything this side, that's going to agree. So meaning k must come from negative infinity to 2 minus 2 root 2. Then this was open, because this is just greater than. Then union 2 plus 2 root 2. Then we have up to positive infinity. So this is how you handle any of those questions there. The same applies to the last one there, guys. When they say it has complex roots, meaning the discriminant is less than 0, and it matters what you get as your discriminant. So if what you are getting as a discriminant is also a quadratic, meaning you have to solve that quadratic, then get the answers, then test. That's what we do. But if the answer is straightforward, like how we got the 9 previously, you'll just go forward and then give it to them. So this is basically what they mean. So here they're saying the number E, k squared, so kx squared. This is plus 4, 3x, then plus k is equal to 1. So this has complex roots, so meaning we're just saying 4 root 3x plus k minus 1. This should give us a 0, because we should always have the thing equated to 0. Then if it has complex roots, it means that the discriminant is less than 0. So b is this, b is 4, that, then minus our a is k, then our c is just that. So the inequality will still hold. So this is going to be 16 by 3, because 4 to the power 2, that's 16. Root of 3 times root of 3, that's simply, a 3, that's a 3. Then here we're going to get minus 4k squared, then plus 4k. This will simply be 48, 4k squared. Okay, so this is 4k. Then from here we try to gather the like, there are no like terms here, right? We just rearrange this to suit a normal quadratic structure expression. So this is going to be -4. So I can just divide this by 4 throughout, because I'm seeing that these numbers here can be reduced by 4 because 4 is a multiple of them, right? So I just want to deal with something that's small. So this will just be a 12 minus a k squared plus a 4 plus the k. Is it? Okay, so we're just saying this is just going to be k, less than that. So negative k squared, then plus k. So this is what you get as the discriminant expression. We have to solve this now. The product is what? The product is -12. A times C. The sum is just 1. So what numbers can we use to get that? And also add them to get this. So we can use this. So we have negative k squared minus 3k plus 4k plus k. This is negative k. Then you have k plus 3. Then this will just be, this is a 12 here, guys, at the end. Then this is a k here, so yeah, so this is going to be a 4, then x plus 3. So would have had k plus 3.
Yes, sir, not x.
Pardon, which one?
There.
Where? Let me
Yes.
just. This has to be k, right? Because yeah.
Yes, and below.
Oh, okay, here, yes, thank you. This has to be, yeah, this is a k, so we are also having negative k plus 4. So when you solve this, you get a k is equal to -3. You solve this, you get k is equal to 4. So now we have to test to see. So there's a -3, then there's a 4. We just put these guys, because we got them, we'll put them aside here, we'll use them. Negative k plus 4. Where is this whole thing going to be less than 0? We want where it's less than 0 this time around, because the discriminant is supposed to be less than 0 when you have complex roots. Yeah, so now you just choose any number that you want. We can use -5. This is going to be negative. That's going to give us positive. This will be negative. Choose any number here. That will be positive. Yeah, this will be positive. You choose any number this side. That will be negative, that will be positive, this will be negative. We want where it's less than 0. Yeah, so meaning it's -infinity to -3. Or it's just open because it's strictly less than, right? So yeah, it is going to be open. This is the infinity symbol, then union from 4 to positive infinity. Yeah, so this is basically what we do there. Any questions here? Daniel, this was your question. Are you seeing what we have?
Yes, I'm listening.
So even the last one there, Daniel, it's the same thing. You just have to pay attention to the condition they're giving you at the end. So they are saying the expression there has roots whose product is 1/2. So we know how we get the product. The product of anything is simply C/A, right? We know that. But they're telling us to say the product is 1/2. So C/A should give us what? 1/2. The problem is given as k squared, x squared, minus 8x, then plus k plus 4. So your A, according to this, your A is k squared, your B is -8, your C is simply k plus your 4. So replace, we're going to say where there's a C, put this, that's k plus 4. Then where there is A, put the value of A, which is simply k squared. We cross multiply, this is going to be k squared is equal to 2k plus 8. This will be k squared minus 2k, then minus 8. We solve this quadratic now. The product here is -8. The sum is -2. What numbers can we use? We can use what? 4 and -2. Is it? Or -4 and 2? Yeah, so that when you multiply, so we have this 4k plus 2k. This will be k, then k minus 4, then 2k minus 4. So just get k is equal to -2 or k is equal to 4 based on the answers that we got, which is k plus 2 and k minus 4. So this guy here, is there a need for us? They're telling us, yeah, we did this. So we've gotten the two values for k is what? -2 and a 4. So you replace in this equation here. Which one will give us 1/2? So here, if you replace with either the 4 that you've gotten. So if you put 4 there, this is going to be 4 plus 4. That's 8. Then down here, 4 squared, that's 16. So this is going to work. So k can be 4. So 4 has worked. We try -2 as well. If I put -2, I put -2 there, that's going to be -2 plus 4, that's going to be 2. I put my 2 there, that's going to be 4. I can cancel this 1/2, okay? So meaning these are both solutions that can give us a quadratic whose product is, so hence k has to be -that, and also k can be this. So this is what we have. Yeah, so they were saying has roots this. We're looking for the values of k. So these two will be the values of our k. Is this okay, Daniel? This is okay, right? Okay, so if there are no questions, guys, we'll end here. Our time is up here. But please try to find time to go through the quiz sample that I forwarded in the group. It will help you to look at hard things. Because if you're able to handle hard stuff, practical questions from papers, then the ones from tutorial sheets are going to be easy.